Hello. Hello and welcome to this video. First, I'll show you how to download the book and then we will solve the problems. So you come to my website astavakra.org or www.astavakra.org and you see you will have this page. You click on the second link, okay, and the PDF will be downloaded. Once it is downloaded, you can click this save button on your browser. It may look different in Google Chrome or Edge or Safari, but you will have something like this. You click this and save the PDF. Don't worry about it. I will give the link in the description of the video. So without further ado, let's get started. So the first thing we need to do is clear up question number 275. I said that the question was wrong. So the question was indeed wrong. The question reads that if sum of the roots of the equation x square minus px plus q is equal to 0 be m times the difference, prove that p square into m square minus 1 is equal to 4m square q. And indeed the solution is like that. Alpha plus beta is equal to p and alpha beta will be q, where alpha beta are the roots of the equation. And sum of the roots alpha plus beta is m times alpha minus beta. And you square both sides and substitute the values to arrive at the result. So in this set, we will solve question number 281 to 290. That is, that's the wrong one. So, okay, fine. So question number 281 to 290, 29th set of problems we will solve. So without further ado, let's get started. And as always, I will say that when I am reading the problem, you should pause the video. And only if you cannot solve the problem, you should look at the solution. So question 281 says that if one root of the equation x square plus px plus q is equal to 0 be the square of the other, then show that p cube minus q into 3p minus 1 plus q square is equal to 0. So we let alpha to be one of the roots, then alpha square would be the another root. So alpha plus alpha square, sum of the roots would be minus p. Oh, this equation is wrong. This should be x square plus px plus q. Okay, I'll fix that. So alpha plus alpha square is equal to minus p and alpha cube is equal to q. Okay, then we see that p cube is equal to minus alpha cube into alpha plus 1 whole cube. And then we substitute for alpha cube. Alpha cube is q. We put it there, and alpha plus 1 whole cube will be alpha cube plus 3 alpha into alpha plus 1 plus 1. And then we substitute the value of alpha cube inside that and alpha plus 1. So it becomes minus q into q minus 3p plus 1. And from these two equations, we see that the equation which we can obtain is p cube minus q into 3p minus 1 plus q square is equal to 0. Now we move on to question 282. It says that if alpha beta be the roots of the equation 2x square plus 3x plus 4 is equal to 0, find the values of alpha square plus beta square and alpha by beta plus beta by alpha. Let me put it in continuous mode and this too in continuous mode. Okay. So the equation is 2x square plus 3x plus 4 is equal to 0. So sum of roots would be minus 3 by 2 and alpha beta would be 2. So alpha square plus beta square would be alpha plus beta whole square minus 2 alpha beta, which is 9 by 4 minus 4 is equal to minus 7 by 4. And alpha by beta plus beta by alpha would be alpha square plus beta square by alpha beta. And we substitute from this equation the numerator, that is minus 7 by 4 alpha square plus beta square minus 7 by 4 we put here, and alpha beta 2 we get minus 7 by 8. Question 283 says that if alpha beta are the roots of the equation x square plus bx plus c is equal to 0, find the value of alpha square by beta plus beta square by alpha in terms of ABC. So sum of roots would be minus b by a, that is alpha plus beta is minus b by a, and product of roots alpha beta would be c by a. Now our given expression is alpha square by beta plus beta square by alpha. We take LCM, we get alpha cube plus beta cube by alpha beta. Alpha cube plus beta cube can be written as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta by alpha, and denominator would be alpha beta. We substitute alpha plus beta whole cube, we get minus b cube by c cube. We substitute alpha beta, we get c by a, and then again b by a. Minus minus becomes plus. And denominator would be c by a. So final sum would be 3abc minus b cube by a square c. Now, question 284 says that if alpha beta are the roots of the equation x square plus bx plus c is equal to 0, prove that square root of alpha by beta plus square root of beta by alpha plus square root of b by a is equal to 0. We have solved similar question earlier as well. Let me show you. Okay. I clearly remember. Yep, this equation. This is a similar equation. Question 223. So now we move on to not move on to, we solve this problem. Okay, alpha beta roots here, alpha by beta plus beta by alpha. So this is the ratio, p by q was the ratio. We substitute p by q here. In any case, we will solve this. Okay, so the sum of roots will be again minus b by a, and sub product of roots alpha beta would be b by a. Now given equation is this. So we take LCM of the first two terms, we get alpha plus beta by square root of alpha beta plus square root of b by a. Now alpha plus beta is minus b by a, and alpha beta would be c by a. So the square root of alpha beta, what is the equation? Oh, the equation is something wrong here. It should be b by a, okay? It should be x square plus bx plus b equation, otherwise it won't work, okay? Let's assume that the equation is x square plus bx plus b. So alpha beta is b by a, and then we substitute here b by a, square root of b by a, and then you cancel out, it becomes 0. So there are two questions where things are wrong. One is this equation in 281. This equation is wrong, and then this equation is wrong. Okay, 284. All right. But let's revisit why this is problematic, okay? Let's see the other equation. Okay, so this case, this is c by a. Okay, you see the difference. In our case, it is b by a. If this would have been different, then it would have been different. Okay. So we'll assume that the equation is x square plus bx plus b for us. Okay, this I'll fix. Question 285 says that show that the two equation x square minus 2x plus b square is equal to 0 and x square minus 2bx plus b square is equal to 0 are such that the gm of the roots of one is equal to the am of the roots of another. Okay. So the product of roots of the first equation is b square, and sum of the roots of second equation is 2b. So product is b square here and sum is 2b here. Okay. Geometric mean of roots of the first equation is equal to square root of the product of roots. So geometric mean of roots of first equation is b square by 1, and you take square root of that, you get b, and square root of product is equal to square root of the products of the roots. That's what we have here. So imagine gamma delta are the roots, then gamma delta is equal to b square, and square root of gamma delta is b. Arithmetic mean of the roots of the second equation, that is half of sum of roots, is 2b by 2, that is b. And we see that geometric mean is equal to arithmetic mean. Now we move on to question 286. If sum of the roots of the equation px square plus qx plus r is equal to 0 be equal to the sum of their squares, show that 2pr is equal to pq plus q square. So we let alpha beta be the roots of equation, then alpha plus beta is minus q by p, and alpha beta is equal to r by p. Given that sum of roots is equal to sum of square of the roots, so alpha plus beta is alpha square plus beta square. Now we substitute alpha plus beta is equal to minus q by p, and alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. Now we substitute the values in this, q square by p square minus 2r by p, and we get the desired result. Question 287 says that if alpha beta be the roots of the equation x square minus px plus q is equal to 0, prove that alpha square by beta square plus beta square by alpha square is equal to p to the power 4 This should be ideally, I don't know, maybe q to the power 4. But let's say q square minus 4p square by q plus 2. Okay. So we let alpha beta to be the roots of equation, then sum of the roots is p and product of roots is q. Now given expression is alpha square by beta square plus beta square by alpha square is equal to alpha power 4 plus beta power 4 divided by alpha beta whole square. Now we can write alpha power 4 plus beta power 4 as alpha square plus beta square whole square minus 2 alpha square beta square. Now we see these two terms, alpha square beta square will get cancelled, we will have 2, and alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta whole square, and that will be divided by alpha square beta square. So this is nothing but p square minus 2q whole square. So indeed the final expression is p to the power 4 by q square minus 4p square by q plus 2. So my doubt was baseless. Now we move on to question 288. If alpha beta be the roots of the equation x square plus bx plus c is equal to 0, find the value of 1 by a alpha plus beta whole square plus 1 by a beta plus b whole square. So again, sum of roots would be minus b by a and product of roots would be c by a. We have to find 1 by a alpha plus b whole square plus 1 by a beta plus b whole square. We take LCM and we expand, we get a into alpha square plus beta square plus 2ab into alpha plus beta plus 2b square divided by a square alpha beta plus 2ab alpha plus beta plus b square whole square. Now we substitute for sum of roots and alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta, and then we simplify, we arrive at b square minus 2ac by c square plus c square a square. Question 289 says that if alpha beta be the roots of the equation lambda into x square minus x plus 5 is equal to 0, and if lambda 1 and lambda 2 are two values for which the roots alpha beta are connected by the relation alpha by beta plus beta by alpha is equal to 4 by 5, then prove that lambda 1 by lambda 2 plus lambda 2 by lambda 1 is equal to 254, and lambda 1 square by lambda 2 plus lambda 2 square by lambda 1 is equal to 4048. So this will be a bit long question. So we have this equation lambda x square plus x into 1 minus lambda plus 5 is equal to 0. So sum of roots would be lambda minus 1 by lambda and product of roots will be 5 by lambda. Now given that alpha by beta plus beta by alpha is equal to 4 by 5, we take LCM and simplify. We obtain an equation in lambda which is lambda square minus 16 lambda plus 1. That means lambda 1 plus lambda 2 will be 16 and lambda 1 lambda 2 is equal to 1. Then the first expression is lambda 1 by lambda 2 plus lambda 2 by lambda 1. We take LCM and we simplify lambda 1 square plus lambda 2 square as lambda 1 plus lambda 2 whole square minus 2 lambda 1 lambda 2. And then we substitute. This would be 16 square, that is 256, and this would be 1. So 256 minus 2 would be 254 divided by 1. So the result would be 254. And then the second expression is lambda 1 square by lambda 2 plus lambda 2 square by lambda 1 is equal to lambda 1 cube plus lambda 2 cube by lambda 1 lambda 2. We write lambda 1 cube plus lambda 2 cube is equal to lambda 1 plus lambda 2 whole cube minus 3 lambda 1 lambda 2 into lambda 1 plus lambda 2. And then we substitute lambda 1 plus lambda 2 is equal to 16 and lambda 1 lambda 2 by 1, and we will have the value of 4048. Now we move on to the last question of this set, that is question number 290. 290 says that if alpha beta be the roots of the equation x square plus px plus q is equal to 0 and gamma delta be the roots of the equation x square plus rx plus s is equal to 0, find the value of alpha plus gamma into alpha plus delta into beta plus gamma into beta plus delta, and second is alpha minus gamma into beta minus delta plus beta minus gamma into alpha minus delta, and last we have to find alpha minus gamma whole square plus beta minus delta whole square plus beta minus gamma whole square plus alpha minus delta whole square. So from the given equation we will have alpha plus beta is equal to minus p, alpha beta is equal to q, and similarly gamma plus delta is equal to minus r and gamma delta is equal to s. Now first we have to find alpha plus gamma into alpha plus delta into beta plus gamma into beta plus delta. We multiply, we get alpha square plus alpha gamma plus delta into gamma delta, and beta square plus beta into gamma plus delta plus gamma delta. We substitute the values of gamma delta and gamma plus delta in both the equations. We get alpha square minus r alpha plus s and beta square minus r beta plus s. We multiply both of them, we get alpha square beta square minus 2 alpha beta whole square plus s beta square minus r alpha square beta minus r square alpha beta minus rs beta plus s alpha square minus rs alpha plus s square. And then we further simplify to obtain the final result as q square plus prs plus s into p square minus 2q plus r square p minus rsq plus s square. The second equation which we have is alpha minus gamma into beta minus delta plus beta minus gamma into alpha minus delta. We put the values, we get alpha beta minus alpha delta minus beta gamma plus gamma delta plus alpha beta minus beta delta minus alpha gamma plus gamma delta. We simplify this, we get 2 alpha beta plus 2 gamma delta minus alpha plus beta into gamma plus delta. We put alpha plus beta is equal to p and gamma plus delta is equal to r. We get the value as 2q plus 2s minus pr. And the final relation which we have to obtain is alpha minus gamma whole square plus beta minus delta whole square plus beta minus gamma whole square plus alpha minus delta whole square. We write this as 2 into alpha square plus beta square plus gamma square plus delta square minus 2 into alpha plus beta into gamma plus delta. So we write this as 2 into alpha plus beta whole square minus 2 alpha beta plus gamma plus delta whole square minus 2 gamma delta minus 2 into alpha plus beta into gamma plus delta, and then we plug in the values. We get the final result as 2 into p square plus r square minus 2q minus 2s minus 2pr. So with this, we come to the end of this set of problems. I will fix question number 284 and 281. Okay. 284 can be written in two ways. Okay. If you look at 284, if you want to fix it, there are two ways. One of the ways is you change the equation, and the second way is you change this value. Okay. So there are two ways you can fix it. So I'll make it x square plus bx plus b. Okay. So that it gets fixed. So with this, we come to the end of 29 set of problems. I hope that you are enjoying this series of videos and finding it useful for your studies, doubts, concepts, and for your exams, or otherwise if you are preparing for competitive exams. So I wish you luck with your studies, and if you are new to the channel, make sure that you subscribe to the channel, and do not forget to like the video and share it on social media so that the reach of the video increases. That is the entire purpose of recording these videos, is that I want to help as many people as possible. And you see that it takes quite a bit of work to prepare these videos, because you see, to prepare these videos, I have to uh, make this PDF, and you see it is almost 1,000-page PDF, and it takes quite a bit of effort to maintain this PDF for you guys. And this is free for download. You don't have to pay anything to me, and you can share it with your friends. There are no cost involved. You can't buy a hard copy of this PDF because I don't have any intention of publishing it. And not only this, I have also created a trigonometry PDF here. The chapters are complete. I have not uploaded it. I'm working on the last chapter. So even this chapter, if you see last chapter, 43 questions are complete, while there are, I think, 54 or 55 questions are there. So this is also complete on my desktop, but I have not uploaded it. So the essence is that I take quite a bit of effort for you guys by preparing this PDF and video. And if you subscribe and like the videos, then that would be a lot of help. Also, if you have questions or you have doubts, or you want to correct certain errors in the videos, then please make use of the comment box. And thanks a lot for watching the video. Enjoy.